Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the chapter Magnetism and Matter. Okay, so let's start the video. Question is, a long solenoid with 1000 turns per meter has a core material with the relative permeability 500 and volume 10 to the power 3 centimeter cube. If the core material is replaced by another material having relative permeability of 750 with the same volume, they are telling volume is same, with same volume, maintaining same current of 0.75 ampere in the solenoid. Now, the fractional change in the magnetic moment of the core would be approximately x by 499. Then they are asking what is the value of the x. So after observing the question, you can see very well what is changing. Only the core material is changing. If we talk about the current, this current is a constant. If we talk about the volume, this volume is also constant, is it? And if we talk about the number of turns and all that, that is also constant. Okay, so let's note down here the number of turns, that means small n, number of turns per unit length, what is given here, 1000 turns per meter. And when we are using another material, the number of turns we are not changing, that means constant. Okay, and if you talk about here the volume is also constant. How much it is given here, you can see very well, 10 to the power 3 centimeter square. This is also constant. Volume is not changing in a second situation. If we talk about the current what is given here, see, the current value is given here 0.75 ampere, and that is also constant. In second situation also using the same. Okay, so this is also constant. After that, relative permeability. In first case, what is the relative permeability of the material? 500. So I will write here relative permeability means mu R1. First case, mu R1, what is given here? 500. Okay, and after that we are replacing with another material. What is given here, you can see very well, 750. Okay, and in the question what they are asking here the fractional change in the magnetic moment. Okay, so if I write here the fractional change is given by this one here, m2 minus m1 by m1. This is called here the fractional change is there. Okay, later you will see that this one we can write here m2 by m1 minus 1. Okay, this is the fractional change in the magnetic moment. This thing we have to do. This is the scenario of the question. Okay, so now after that, to solve this question, we have to use very popular formula, you know very well. If I talk about the relation between relative permeability and the magnetic susceptibility, so you know very well one relation is there, mu r equal to 1 plus JEE. Mu r is the relative permeability, JEE is called magnetic susceptibility. Okay, and here if I go to the next step, I can write here, see, this mu r minus 1 is equal to what is given here, magnetic susceptibility JEE. Okay, so see here, we are just making the formula. This magnetic susceptibility is the ratio of I means intensity of magnetization and H. This H is called the magnetizing field. Again I am telling, I is the intensity of magnetization and H is the magnetizing field. Now we have to put these values because we want magnetic moment. So remember that here this intensity of magnetization, I is given by capital M, that means magnetic moment by volume. I equal to, what is the formula? I equal to M by V. Similarly, if I talk about here H is called the magnetizing field, only depends upon the number of turns per unit length and the current that is flowing. So H equal to Ni. These two formulas are very common here. Okay, so these two formula I am going to use here. So what we can write here, can you see it? Very easy, see. So mu r minus 1 is equal to the value of I means capital M by V, magnetic moment by volume. Okay, and what is H? H is given here Ni. Okay, so next one, let's see here. this one mu r minus 1 is equal to, I can write here, m by v n I. So this magnetic moment is given here what? See, mu r minus 1 into v n I. This is the formula is there. Okay. So this is the formula, this is the multiplications here. Okay. So here you can see very well, V is the volume, N is the number of turns per unit length, and I is the current. Now let's see what are the things are constant. So you can see very well, even V is constant when we are changing the material, core material, V value is not changing, N value is not changing, I value is also not changing, it is same only. Okay. So what can we tell that as V and I is constant, so hence we can tell here M is directly proportional to mu r minus 1. This is the situation. Okay. So after that what we can write here, see, we have to calculate here what a fractional change, is it? So now we can write here the fractional change as I told in the starting. So fractional change in M. M is what? Magnetic moment. Is what is the formula I told you in the starting? See, M2 by M1 minus 1. Is it? Now you know very well M is directly proportional to mu r minus 1. So I can write here what? Let's see here. This will become here mu r2 minus 1 by mu r1 minus 1, and here minus 1. Okay. And this 2 and this 1 in suffix. Okay. Great. Now if I talk about here the mu r2 value, what is given here? 750. Mu r1 value, what is given here? 500. Okay. So we'll write now here. So 750 minus 1 by 500 minus 1, and here also minus 1. So what this will become here? Let's see. This will become here 749 by 500 minus 1. That means it will become here 499 minus 1. And when you will take here the LCM, so 749 minus 499, it will come here 250 by 499. This is the situation. This is coming value. So fractional change in magnetic moment is coming 250 by 499. Can you see very well, students? Okay. So this one we have to compare with which one? We have to compare with x by 499. So you can say here 250 by 499, I have to compare with x by 499. So you can see very well what is the value of the x. This is the x, and this is coming here what? 250. Is it? 250 is there. So you know very well the value of x, how much here? The value of x should be, we can tell here 250. The value of x is what? 250. This is the answer. Okay. Can you see here? So students, I hope so. This video based upon the concepts, basic concepts of magnetism and matter is very, very clear to you. Keep studying, keep growing.